Welcome to this launch status news conference for Space Shuttle Endeavour's STS-134 mission to the International Space Station. We have two NASA managers here today to give us an update on the latest preparations for our next launch attempt for Endeavour. First, we have the Space Shuttle Launch Integration Manager, Mike Moses.
Good afternoon.
And finally, we have Shuttle Launch Director, Mike Leinbach.
Good afternoon.
We'll start with opening comments and then go to questions. Sir?
Right, thanks, Alan. Let's see, just to recap, the failure that caused us to scrub on launch day was the signature we saw was a heater over on APU-1, that's Auxiliary Power Unit number 1, a system that burns off hydrazine to spin a turbine and create, or spin a pump then that creates hydraulic pressure and provides hydraulic pressure to the aero surfaces and the main engines. One of the fuel line heaters was not working. We saw the temperatures dropping really low. Turns out after doing all the data review and taking in what we've learned in on-ship testing, there were actually 5 separate heaters that had failed, and we traced the commonality back to a power supply, what we call a hybrid driver, up in a box we call the LCA, the Load Controller Assembly. In this case, it's number 2. There's 3 of them in the aft compartment that feed power back to the systems in the back of the orbiter. So ALC number 2, Load Control Assembly number 2 failed. A part inside it, and that's a common cause. So we went in and we looked and we pulled that box out, and we've done troubleshooting on it. And inside that box, there's a whole bunch of cards and circuits. On the particular one that we were interested in, we saw what we call a fusible link, which is literally a little piece of gold wire that bridges a gap between 2 elements of that circuit card, had blown, which effectively is a fuse to tell us that that piece had seen high current. And the cause of that high current is still kind of unknown, and we're not sure exactly where it came from, but we know where it impacted, and by blowing that link, that took that driver offline and prevented it from providing any power downstream. So the failure on launch day was a failure of having power supplied to the heaters. The cause of that failure to supply power, we're still not exactly sure of, and so we went through what we call our unexplained anomaly troubleshooting, which basically, when you don't have an exact root cause, what are you going to do next? And for that, we basically started attacking the different components in the system. We knew we were going to change that box itself out, the ALC number 2, the Load Control Assembly number 2 box, and we had the new box ready to go and put in. And I think we actually have some video, right? We might as well go ahead and run that while I'm talking. This will be showing you the technicians going into the Endeavour out at the launch pad, going in through the aft access door, which you see right there, to get into the aft compartment and head into Av Bay number 5, which in this view is over their heads, and remove that failed box. And it's about the size of a pretty good-sized shoebox, and it's got a whole lot of electrical connections on the back end of it. And so you can see the technicians removing that box. As we've told you before, the big issue with this box is after you put a new one in, retesting all the components that it feeds. Once you disconnect all those electrical connections, and you'll see a shot here shortly of the side of that box where all the electrical connections are. There you are. Each one of those has multiple cables hooked up to it and hundreds of wires. And so every one of those functions has to be checked. The box went down to our logistics depot, or the NSLD down in Cape Canaveral, where they removed the cover. Here you'll see what I'm talking about. A whole bunch of wire in there and a whole bunch of little gold cards. Each one of those is a module that affects given systems. So in addition to trying to find the cause of the short in this box, we have to retest each one of those systems because we've reconnected the lines, and you want to make sure you had good copper path electrical connections. So you can see, they'll show you a close-up here of one of the gold chips. We know the failure's on one of those little cards, but you don't know if it's on any of this wiring upstream. There's still a whole lot of what we call external failures, and that doesn't necessarily mean external to the box. It just means external to the little hybrid driver electrical component on that box. And so the failure still could be inside that box, or it could be outside. And here you're back in Av Bay 5 again, and they're doing some checks on the wiring in the actual orbiter. And basically the wiring run. So let me back up for a sec. So that takes care of the box. We're going to put a new box in. We don't know exactly that the failure was or was not inside the box. We're going to continue to do some failure testing on the box itself, but it's going to take a little while. So we started off with the next component on the ship, which is the orbiter wiring. And so if you think about it, the wiring takes it outside this Av Bay, which is basically a giant set of racks where we hook up all of our electronic components in the aft compartment. This particular one is on a cold plate, a Freon cooled plate to keep it cool and take the heat away from it. And so in that av bay, there's a whole bunch of connections and wiring that runs and goes through a bulkhead and then passes out into the aft compartment itself, which is the big, I call it the open area. If you've ever looked inside there, it's not very open, with all the plumbing and electrical systems and main engine power heads and APUs and water spray boilers and everything else on the back end of the ship is back there. So it's not really open, but that's where the wiring would then run across from the left side, the starboard side, over to the port side, and then down to APU-1. Here's a good picture of the wiring itself. You see, in typical protection, we have convoluted tubing. That's the black tubes running. Basically, those are covering up all the bundles, so the wiring is inside there. You can't see it. There's chafe protection. You can see on all the clamps, the orange foam material is chafe protection. There's overwrap and arc protection put on. That's some of the clear white and light brown material. And what we did was I'm getting ahead of myself, but while the picture's up, you can kind of see running right through the middle of the picture, there's a twisted pair of 2 wires, black and white. It's been called licorice wiring running across, but basically you can see what's the equivalent of 4 wires running along a cable. So we didn't want to go in and rip open all these cables and replace all the wiring, but we did want to put a new run in just in case the short was in that orbiter wiring. So you can see we kind of spot tied along the outside, and this is a typical way we'd hook up in case we needed to bypass orbiter wiring. So we basically redid and relayed in wiring runs, and that runs all the way down from the av bay all the way out to the heater. So let's see, while that picture's up, I can talk a little more, or we can take that down if everybody's got a handle on it. So I was kind of talking about the av bay itself. So we replaced the wiring from the box connection inside the av bay until we go out of the bulkhead of the av bay, and then we replaced the wiring from the outside of that bulkhead in the av bay all the way down to the heater itself. And I forget the total number of feet that we replaced, but it did go from one side of the ship over to the other. And so that's kind of a typical response when you get an unexplained anomaly in orbiter wiring that is a potential short condition. You really want to find it because it is an electrical short or an electrical open circuit. And if you can't find it, the common cause or the common method of troubleshooting that is to replace what you can do. So we replaced the box. We didn't want to replace, per se, the wiring, but we did lay in brand new wiring. So we've kind of effectively taken the existing orbiter wiring out of the equation by rerunning it. And then the last thing left is the heater itself on the lines. And this line runs from the APU fuel tank down to the APU itself, and then there's various test ports and service lines that run off of there. All of that has to have heaters wrapped around it to keep it warm while it's in orbit. You don't want that stuff to freeze. Hydrazine freezes about the same temperature as water, close enough anyway. And you don't want to let that freeze up and then thaw. You could put some pretty high pressure cycles into the system, and that could then cause the plumbing to rupture and cause a leak. Hydrazine leaking into the aft compartment would be really bad. Once we got back in the atmosphere and got oxygen in there, you'd likely have a fire condition. So our rules and our procedures are set up to do everything we can to make sure we have no leakage of hydrazine in the aft compartment. So we looked at the heaters. Replacing all the heaters would be a very invasive process because there's 2 heaters on each line, an A and a B. They're kind of overwrapped around each other. They're wrapped around that line, and then that line itself has insulation put around it. So they're effectively double protected from an insulation standpoint. And you'd have to basically go in and remove all of the heaters on APU-1. And you really risk a lot of collateral damage to other systems while you're doing that. So we talked a lot about how do we go about making sure we have confidence in the heaters, since we didn't really want to replace those heaters from an intrusive standpoint. There's thermostats that are on each of these heaters. There's a control thermostat, just like you have in your house, to say if it gets too cold, turn the heat on. If it gets too hot, turn it off. And then we have a second thermostat a little further downstream called an overtemp thermostat, which is basically an independent thermostat that says if this heater failed on, turn the power off, so that you wouldn't want to heat this line up. Again, just like you don't want to let hydrazine freeze, you don't want to let it get so hot it starts to boil and cook off. That could cause a problem as well. So there's overtemp thermostats to prevent failed on heaters. So we went in and we replaced all those thermostats. That was a fairly easy thing to do on the heaters, but again, we didn't want to touch the heater elements themselves. So we ran a whole bunch of tests, and they have a whole bunch of fancy names, but effectively we did continuity checks, which is what you'd do if you basically hooked up a voltmeter from one end to the other and made sure that wire was intact. It didn't go to ground anywhere. The resistance, we measured the resistance of that line. It measured within family of what the resistance of this heater measured the last time it was checked about 2 years ago. So we saw no changes in the resistance of these heaters. We saw no open circuits with the continuity checks. We did what we call a high pot or a high potential check. of all the orbiter wiring and the heaters, where you basically put in a high voltage but low current into the system, and you'll see that voltage jump across any gaps. If there is an insulation breakdown, it would show up as that high pot test grounded itself out, and we found no problems in either the orbiter wiring or in the heaters. And then we did functional checks, which culminated. We did various checks all along the point, but culminated last night in our full-up retest of this APU system, where we basically operated the heaters on both an external power supply and then the new LCA2 power supply, which was done last night. And we saw full functionality out of all 5 of these heaters as they were supposed to work. So we've kind of end-to-end checked and wrung out the whole system. You could say that we did the same tests on the orbiter wiring and saw no problems. So you'd ask why we replaced that wire, and literally it came down to we could do it easily enough, and it removed a variable. One of the concerns we had on launch day, the reasons why we weren't ready to talk about launching with one of 2 heaters failed, in addition to the loss of redundancy, is kind of the unknown cause. Could this failure be a problem inside the control box, which could take out other functions in the box? So we didn't want to go with that. We now know that this was isolated to a single circuit. That's not a problem anymore. And you didn't want to go if you had a problem in a wire bundle that could propagate itself to other wires in that bundle. If you remember that picture of the wiring covered up by that convoluted tube, there's probably 100 to 200 wires in that bundle. So in addition to the 5 heater circuits that we're talking about on this APU, there's 100 or more other circuits, and you'd hate for one of those to take a short and also lose functionality. And so we'd be worried about wiring. Adding this new external wiring run effectively removes that from our risk charts as well, so we don't have to worry about a wire-to-wire problem inside a bundle by running new wires. So that kind of leaves us with, of all the components, the box, the power supply, the wiring to get you the power out to the heater, and then the heater itself. We've replaced everything except the heaters, and we've rung those out with at least 5 separate checks and full functionals afterwards, and now have extremely high confidence that the problem is no longer on the ship or in any of the electronics. We don't still exactly have root cause, but we basically have really good comprehensive proof to show that we have managed to remove that failure. If you remember that picture of what the box looked like and all the little wiring inside that box, to go sort through wire by wire to look for a sign of a burnt wire or a scorch mark is going to take a very, very long time. We kind of took a high-level approach, and we put that box on the bench, and we vibrated it to see if anything shorted, and we saw nothing. And now they're going through some deeper tests, but it's going to take a long time till we could say that we've definitively found a problem inside that box. And so we wanted to make sure our flight rationale didn't need us to have that root cause. And by replacing the box and replacing the wiring, we think we have that. Now, I have some new data that just came in literally as I was walking over here. We did test these heaters. We were testing thermostats, actually, back in June in the processing facility, and we saw what you're really testing is that when you heat up the overtemp thermostat, that it does cut out and stop the circuit. And so it did what it was supposed to. It stopped functioning. But if you look really close at the data, there was a spike of current right before that happened, much higher than we've ever seen before. Now, this is really preliminary, and we're not exactly sure what caused it, but if it was a short, that would be an indication of this was isolated to either the heater or the thermostat on one of these circuits. And we've actually replaced all that wiring as a result of our troubleshooting, and so we should be in really good shape. Now, we have to finish all that data review, verify that that truly was the problem, and then re-verify that we ran that test again literally last night, and then it didn't reoccur at all. All the preliminary looks make it look like that's exactly the case, and we actually have, if this truly turns out to be the root cause, we've removed it from the ship. But again, that's pretty preliminary, and so I was about to say we have extremely high confidence that we got nothing in front of us to prevent us from launching on the 16th. Pending this review of this new data, assuming it turns out the way we think it does, we've already done the work that would be required, so there should be no threats to the 16th launch date. So let me stop talking about wiring and boxes for a second and let you know. So we went ahead this morning and said, looking at the work in front of us and talking to Mike's team, we finish up ordnance and retest, and that effectively puts us on what we'd call a normal closeout and prep for launch. And so his team and the flow managers had very high confidence in our ability to make that schedule. And so we did set the launch date officially for 5/16 with a launch time of 8:56 a.m. Eastern Time on Monday the 16th. Now, part of that analysis was happening back in Houston as well to make sure that we could understand the mission impacts. You know, we talked back when we scrubbed that one of the things we needed to look at was that the 25 Soyuz crew undocks on the 23rd of May, and we wanted to make sure that our mission overlapping that wouldn't be a problem. So we've done our technical reviews to make sure that nobody has any problem as a Soyuz undocks and leaves the station. There would be no adverse effects to any of the shuttle hardware, any of the things in the payload bay, and we think that all is coming out just fine and we won't have any issues. But more importantly, we wanted to make sure we had a crew timeline worked out. It gets pretty tricky. The Soyuz crew of Dmitry Kondratev, Paulo Nespoli, and Katie Coleman undock and then effectively land that same calendar day of, it's a good, I think it's about 10 hours, 12 hours later, but they have a very long day. And to get that lined up over a Russian ground site, if you look at the time that undock has to occur based on the time that the shuttle crew needs to be on a sleep shift to set up for their undocking, that Soyuz undock will occur about an hour or so after the shuttle crew goes to sleep. So we wanted to make sure we knew how to deconflict the two crews from each other. We're effectively kind of setting up a second shift. We'll leave the station crew on the timeline they need to be on. The shuttle crew will be on the timeline that they need to be on, and there'll be a little disconnect between the two. So at worst, on the 16th, right before undocking, that'll be about a 4-hour disconnect. So what I mean literally is the shuttle crew will wake up, start their morning, get their post-sleep hygiene break, get breakfast, get stuff ready, and about 3 to 4 hours later, the station crew will wake up and start that task. So for about the first 3 or 4 hours of the shuttle crew's day, the station crew will be still asleep. For the most of that part, the shuttle crew's actually in the shuttle doing their normal shuttle activities and equipment and hygiene stuff, but eventually they're going to have to move into the station and start working. Katie Coleman and Paulo Nespoli are sleeping in the Node 2 crew quarters, but they've talked to them and they've done this before. We understand that if they're in their crew quarters, they're fairly isolated with earplugs in, and they should be able to sleep pretty soundly. We're not doing any work in Node 2. We're just literally passing through on the way to the airlock to do some of the EVA preps or to the cupola to do robotic preps. And it's not very big of an overlap with their crew getting up and starting their sleep activities. And I say that's at the worst case because every day we slowly sleep the sleep shift, the shuttle crew, back to the left to get them set up for their undocking time. So like on EVA days, there's only about a 2 or 3 hour overlap with that crew. So the teams in Houston looked really hard at that. It's a pretty confusing thing to try to figure out, but when you set it down and you look at the relative shift times, they were all comfortable. The crew office was very comfortable that it's a doable thing and it's an achievable thing. So really what that kind of comes down to is after they've left, what tasks were Katie and Paulo doing that they were now no longer going to be there for? Ron Guerin is coming up on, or he's actually already there, so he'll be there as the Expedition 28 crew. What tasks will he pick up that he maybe didn't train for? And it turns out that everybody was trained to kind of do each other's jobs, so it shouldn't be too big of a problem. Paulo was a set of hands in the during the EVAs in the airlock, and we'll kind of backfill that with some of the shuttle crew. And then Katie was doing what we call M2, which is the second robotics operator on the station arm. We'll back that up either with Ron Guerin, or when he's not available, the ground will be able to do that, and that's a typical thing they do on station. They use the ground as a look over your shoulder kind of double check. So the sleep shifting's tough, but they think they have a plan to manage it. So they came back and said that the 16th is a good launch day as well. That does mean we're not going to try to do, even though the Soyuz is leaving, we're not going to try to do a fly out because it will be while the shuttle crew's asleep, and we would not want them asleep if they were going to kind of do a fly around to the station to take pictures. The other big constraint to that is they're actually buttoned up in their descent module and ready to land. The high quality optical window in the Soyuz is out in the orbital module, and it'll be either packed full of return gear and the hatches closed. So that Soyuz crew does not want to get up out of their seats and then go open up and get into that high quality optical window. They have a window through their hatch, and I'm sure they'll take a picture of what they can see, but we're not going to do any dedicated maneuvers, and we don't expect those pictures to be very high quality in the first place just because it's not a window meant for photographs. And so we'll probably get some rough pictures, but we're not expecting much. We're not doing anything specifically to try to take a family portrait of the shuttle docked to the station on this mission. We do have that laid into the STS-135 plan, and it looks like it's going to work for that. So I think that covers a whole bunch of stuff. Let's see. So, mission timelines. We did add 2 extra days. We were at a 14-day mission. We knew we had 2 extra days to use. We went ahead and gave the MOD guys those 2 days right up front to let them put them where they need to. They'll use one effectively the day before the Soyuz undocks. That'll be the kind of the day off where the shuttle crew can kind of leave the station crew alone to let them get their sleep shift down to be able to be ready to undock Soyuz. And then we'll add another one in between EVAs 3 and 4, which is kind of where we were planning on putting some extra activities in the first place. That moves our planned landing out to June 1st. I think the landing time will be sometime around 2:30 a.m. Eastern. That's always kind of subject to change based on little orbital tweaks, but it'll be approximately around 2:30 a.m. on June 1st. And I mentioned 135, so let me go ahead and answer right now. We're not going to be able to tell you a launch date for 135. So for everybody who works at NASA who's listening, everybody who doesn't work at NASA who's listening, I'm really sorry, but we cannot estimate that 135 date. Every time we think we have a plan, something else comes up. For example, Mike and I were just talking, and we had a rollout plan that looked like we were going to be rolling out a couple days after launch, but then we recognized that the VAB rollout would be at the same time as landing. And so we got to go deconflict that. We don't obviously want to be doing that at the same time. We do know we're going to have to slip the launch, and it's going to slip a few weeks. We're going to be in early June. More than that, I'm really hesitant to say, because every time, like I said, we look at a schedule, something else changes and makes us rebalance it. So we're going to wait till we get 134 up in orbit and out of the way. We'll look at the damage to the pad to see what work we have to do to turn it around, and then we'll set the hard and fast launch date for STS-135. So I think I've talked enough, and I think I've taken away almost everything Mike could talk to you about, but I'll let him see what he can tell you.
No, I always learn something sitting next to Mike. Let's see. I don't have a lot to add, folks. We're pretty much we are done with all the troubleshooting of the problem now, and we're into our standard pre-countdown pad closeout work. We'll get into our ordnance installation again tonight at about 2000 hours Eastern Time. That'll take us over the evening, and then tomorrow we'll get into the aft closeout in earnest, and that sets us up for the beginning of launch countdown Friday morning. Shooting for an opening of the launch window at 8:56 Eastern Time next Monday, the 16th. Right now, that all looks good. And there was a heck of a lot of work that's been done since the scrub on the 29th of April. And one thing to mention, we were very cognizant of the workers out of the pad and all the analysts, both here and over in Houston, made sure that throughout the whole process they got sufficient rest throughout the process. And so we feel real good about that. We didn't stress anybody. There was a lot of work going on. It was 24 hours a day, but we had different people working on it at different times. So everybody got sufficient rest and they're ready to go. We'll have our pre-test briefing later this week for launch countdown. That'll happen on Thursday, where all the systems come back together and verify they're ready for the countdown itself. We'll just go over different deltas from the initial pre-test briefing that we did about 3 weeks or so ago. Don't expect anything to come out of that. So right now we're in good shape. Endeavor's looking good. The team is upbeat. I went to the meeting this morning, and they're ready to go. And hopefully this time the heaters will work, and we'll be able to launch on time next Monday morning. So thanks, and be glad to take your questions.
Okay, please wait for the microphone. Give your name, news affiliation, and to whom you would like to have your question answered. And we'll start with the front row with Dan.
Hi, Robert Perlman with CollectSpace.com and Space.com. With a question, I think, from Mike Moses. If, given the crew timeline and sleep shifting and everything else, if you cannot launch on the 16th and weather delays you a couple more days, how does that affect the plans in terms of, and is there a point that you can't launch because the Soyuz undocking's too early in the mission timeline?
So from a sleep shift standpoint, we think we have a good plan to get us through most of that window. The only days right now we'd probably want to avoid would be around the 20th or 21st. That day would put Shuttle docking the same day as the Soyuz undocking, even if we added an extra day in there. And that's obviously something we want to avoid. And the reason I say it's the 20th or the 21st is the day that it would occur, but we could change how we use our extension days to move that around a little bit. That's the work to do that math is pretty hard, and so we're going to start it but put it on the back burner, so I won't have an answer for a while, but if we find ourselves getting there, we'll obviously figure out exactly what day we can and can't launch. But basically, besides that little bit of cutout of a day or two to avoid docking the same day as Soyuz undocking, we'd be good all the way through the end of our window, which I think runs to the 26th or 27th before we hit the 27S docking, which we do not want to be there for. So that would be the end of our window.
And with regards to root cause, understanding that you don't need to know root cause to launch this mission, do you need to have root cause for the failed box before 135 can fly?
No, not necessarily. These kind of things are kind of ship unique events. If it's a wiring short, it might be some damage that occurred in servicing. If it's a heater problem that occurred, again, it's probably something that's collateral damage. So there's no reason to suspect that the same thing happened to the other wiring. If this late breaking data that I talked about that showed that when we were doing over temp thermostat testing, If that in failure analysis anyway shows that maybe that was an induced failure, then obviously we need to go check Atlantis to make sure nothing happened there. But the odds of where this is in the circuit and that occurring are pretty slim. We couldn't really come up with any ways that would occur, that our actual test caused the problem. But if you think about it, the techs are back there right near that hardware. They're flexing it and moving it. So if there was a little bit of an issue in one of the wire bundles, they might have inadvertently, the movement might have inadvertently caused metal-to-metal contact, which then could have caused that spike. There's no reason to suspect that would happen on any other ship, though.
Cheers.
James Dean with Florida Today. I think for Mike Leinbach, you're talking a little bit about the workforce. I wonder if you could say if the pace of the repairs you've just completed was affected at all by reduced staffing you've been through in recent months, and whether it was or wasn't. Just speak a little bit about your ability to overcome some challenges these last couple of flows while all that's been going on.
Yeah, relative to the reduced workforce, it did cause a couple little problems in our APU engineering group. We're down a guy or two in that group, so we had to do some creative work around their schedules. But again, they all got their sufficient rest, and that's probably typical of any problem we're going to pick up between here and the end of the program. We're going to have to look at the people we have left, look at the critical skills we require to solve those problems, and then work around the people. And if it causes to delay a launch or a major milestone a day or two to give the people sufficient rest, that's what we'll do. In fact, we asked that specific question during this whole process. We were very clear with the team that if they felt they needed more time off, that they would speak up, their management would speak up, and we'd give them the time. And to a person, they said, "No, we're ready to go. We're all getting good rest, and so we should be good." The reductions, we're kind of at a steady state right now through the end of the program. So I wouldn't expect any further impacts from a workforce perspective. Again, we meet monthly with the contractor team and NASA management, and we look at each group relative to their strength. That's engineering, technicians, quality, safety, everybody, logistics, payloads, everybody, and make sure that we're ready to go. And again, we wouldn't go if we weren't ready. This time we worked around a couple of schedules and got to the 16th as the launch date. So I feel good about it. I mean, the process works exactly right. People are free to speak up, and believe me, they do. Our workforce is not shy. They'll speak up when they need some time off.
Marcia.
Marcia Dunn, Associated Press, for Mike Moses. I know you didn't have the exact wiring of feet, how many feet were replaced, but could you hazard a guess that how long that strip is that you had to put in?
I don't think I could even guess. Yeah, we've talked a couple of different lengths of wiring, and I think it's maybe in the 20 feet. Yeah, it's probably in the 20 feet plus or minus 10 feet.
I would have said 20, roughly.
How many, 20?
Yeah, it was Mike and I kind of ballparked about 20 feet,
Okay.
plus or minus.
And what about the crowds? Do you think a Monday morning lunch early is going to attract as many crowds as a nice Friday afternoon, end of the week lunch?
I'll say we asked those very questions of the local communities, the Titusville Police Department, Highway Patrol, everybody. And typical for a scrub turnaround, especially a lengthy scrub turnaround, some people won't come back. Monday morning at 9 a.m. is not as attractive as Friday afternoon at 4:30, so that'll keep some of the crowds down. It's still going to be quite full, and we're going to stick to our plan of assessing if we do scrub on Monday morning, looking at the time of the scrub relative to the traffic in town. So it will be less, but it'll be a heck of a lot more than we had for 133, and that's the concern.
Bill.
Bill Horowitz, CBS, with two questions. For Mike Moses, can you give me some more detail on that spike, that late breaking thing? I'm unclear what the test was. Were you only testing that overtemp thermostat when they saw that, whatever the spike was? And also, I'm curious how you know that whatever might have caused that isn't in a heater that you didn't replace that could cause the problem again.
Yeah, so I would have thought that, 25 minutes of talking gave you enough details, but yeah, I have a whole lot to talk about. So that data, like I said, is pretty late breaking. So to answer your second question, we don't know exactly the cause of that. So we do know we were working on that thermostat, and the test was literally to heat up the thermostat, the overtemp thermostat, which effectively says fake it out to make it think that the heaters are running and see if it opens up and kills the power. And it did exactly that. So the check that the guys on console were doing was making sure the current being drawn by that heater dropped to zero. And so the techs are in the back heating it up. The guy's watching the data. He sees it drop off. Only in now looking back with a weather eye at the high-speed data, we see that literally milliseconds before that, a 10 amp spike came in, and that's what actually removed power, not the overtemp thermostat itself opening up. That's the theory being postulated on the table right now. We got to let the guys review the high-speed data again to make sure that there's nothing else going on. Some of this is you have the electrical team who's reviewed that data, trying to judge what the APU team was doing at the time. The two of them need to sit in a room together at the same computer monitor and make sure they truly understand exactly the timeline events, and the team's building that timeline right now. We don't know exactly where that would have been. We've removed that thermostat and the leads. It's down at the depot right now. They're going to do failure analysis to see if we see any kind of short on the wiring of that thermostat or inside the thermostat. You wouldn't expect it inside the thermostat, but the wiring could have been a problem. In fact, this type of wiring in the past has had some problems on thermostats like this before with some faulty wiring. And so we're going to take a look at that. But again, our confidence to fly goes to we didn't really need to know root cause because we've done functionals in multiple ways on all the components. And then we went ahead and replaced a whole bunch of them and then repeated all those functionals. So we know we have really good power heading out to those heaters. We've turned them on. We've run them. We've checked those overtemp thermostats. We've literally run them through all their paces, and they're performing just fine. So we'll button the ship back up. We'll go into launch countdown. We'll chill things down as we load the ET, and we'll go see how these heaters perform again. And like I said, we have very high confidence that nothing's going to happen. But again, that'll be yet another check that the problem's not there in the ship, and then we'll be good to fly.
Okay, thanks. And one more from me. Realizing that you can't tell us when 135 might end up going, I believe you said in your remarks it could be a couple of weeks. You guys had the 60-day notices, I think, for the next round of layoffs. They're supposed to go out this week. And I think some of those layoffs would kick, if you really did slip that launch 2 weeks to around the 15th of July or somewhere in that ballpark. I mean, these things would be happening that could impact processing or not? I mean, I may be confused about that. I was just curious what you have to do right away to kind of straighten that out.
Yeah, you're right. The WARN Act notices are going out, but you got to decouple. A WARN Act notice doesn't mean you are being laid off. It just gives you notice that you have the potential to be laid off. The date originally targeted for those was going to be starting around the 15th of July, kind of in a phased approach just due to the magnitude of the number of people that will be processing out. And then kind of there'll be another batch coming in on July 22nd. That was the original plan based on a June 28th launch date. The rub of it is you got to make sure the cart stays behind the horse on this one. The shuttle launch schedule and supporting the manifest is the true driver, and if we need more time, those people will not be let go and they will stick around and work as long as we need them to. So the plan to send out warning notices still has to happen because we're required by law to do that and notify people there's the potential that you will be laid off on the 15th of July or the 22nd of July, whatever that specific date happens to be. So just like we have to reassess the launch date, the human resource departments and our contractors need to reassess when they need to officially notify the employees. And what you're going to see us do is basically cover the bases by going ahead and notifying them that there's still the potential of a layoff. And it doesn't mean that will actually occur on the date we warned you about, but it's coming. And everybody knows it's coming. And Mike said that pretty eloquently in the past. This is nothing new to our workforce. The specific day is really what it's going to be, what we're talking about. The concept of we're here until 135 flies is still what the team knows is the true milestone.
And just briefly, you did say a couple of weeks. I mean, you said that. I'm just making sure that's what you meant to say.
Yeah, so a couple weeks might be less than that, right? So it's, again, the plus or minus. So I'll say a couple weeks plus or minus a week. We're looking at, I could say we're looking at the second week of July, but is that the second full week of July since July 1st is on the middle of a week? So we're looking in that time frame. And I'm not trying to be coy about it. It literally, if I mentioned a time frame, everybody and not just the public would lock in on that. And we really don't want to do that until we truly sit down and do the work. This is another one of those things that kind of we were talking about is we're being affected by our workforce reductions. We know we can't do rollouts on the same day we do launch. We can't do it on the same day we do landing. In the past, we would have had extra teams to be able to help with that. And so we really do need to make sure that in addition to what the schedule says on the calendar, we then put the workforce profile to that as well and make sure we have the right teams and we're not working anybody too hard. It's just going to take us a little while to work through it.
In the back, Irene.
Thanks. Irene Klotz with Reuters for Mike Moses. Was it a factor to go ahead and add the 2 extension days that only half the station crew would be there for the tail part of the mission?
Not really. It was more just to put that flexibility in up front. When we were talking about this before, when we were trying to launch on the 29th, we were going to hold those 2 days back. We knew we were going to use them, but exactly when and where we would commit them, we kind of wanted to make sure that we docked on flight day 3, that we had all the understanding of what was going to happen in the station timelines. Those concerns are all still there, but the complexity of being able to accommodate the Soyuz undocking in the middle of all this, and to some extent the loss of the crewmen, really made it more sense to give the planners up front and the crew a definite schedule that was probably locked in. So we've identified already kind of where those +1 and +2 days would go. And I say kind of because based on the specific time of the launch, every day we slip, they're going to have to redo their plan. They might choose to switch to a different day, either before an EVA or after an EVA, to just alleviate that particular sleep shifting. So it wasn't a direct thing to say, hey, we're losing 4 hands after undocking, so we need to add an extra day to keep the shuttle crew around to get those tasks done. They were kind of bonus tasks to begin with. It's more of giving the team the flexibility to put the time in the schedule to deconflict the 2 events and really not make it a push. And kind of like we do with our workforce down here, let the folks back in Houston know we're not going to push to make everything fit. Take the time you need to get the activities done the right way.
Thanks. And also on that note, I can't recall any other time that the shuttle crew would have been there when the station crew is leaving. It's kind of like having your host take off and you stay around. Is there anything aside from sleep shifting that is kind of an operational or any kind of concern or issue that you or the station people are having to deal with?
Well, we call this, generically, we call this dual docked ops. And so anytime there's a docking or an undocking of both vehicles, either the shuttle, the Soyuz, or the Progress, and I throw the HTV and the ATV onto that list as well, we need to evaluate the specific constraints on both the shuttle and the station to make sure that that dual docking or undocking can occur. In this case, a Soyuz undocking is pretty straightforward. It literally backs straight out of a port. There are certain docking ports on the station that for a Soyuz or a Progress undocking, those thrusters, if they come off a little off axis, those thrusters plumes could head towards the orbiter windows, which is a sensitive area for us. And so we've ruled out dual docked operations if undocking was occurring from any of those ports. This is not one of those, so we know that's been cleared. So we have a whole bunch of hardware constraints that we wanted to check. For example, the payload bay is sitting there open. The radiators are there, can be impinged upon. We have the OBSS with all its sensitive optics on the end of it. We want to make sure it's not in the way. If you're going to do a relocation, you're going to take the Soyuz or the Progress and fly it around to a different port. Make sure that on its way back in, if it had a failure such that it needed to abort, that abort trajectory wouldn't cause any problems. All that has been generically analyzed. And we've kind of given a generic blessing to do dual docked operations from certain locations. So when this one came up, we knew all that work was behind us. Then it was just the flight-specific analysis, which is the stuff like the timeline, the sleep shifting, the workload on the crew. And that really depends on the specific orbital mechanics of the day to say when are the 2 events occurring relative to each other, and can you build a timeline that allows it. This one's pretty close to the edge. A sleep shift another hour or 2 worse than this would probably tell us we can't do it. So this is about the furthest we'd want to stretch for a dual docked operation. But we know conceptually it's feasible, both in terms of the crew timelines and the vehicle physical hard constraints.
We'll take one more question here, and then we'll go to a question we have on the telephone.
Thank you. Naomi Takimoto with NHK. I just would like to make sure what I heard is correct. You said you can't tell about the launch date for the 135, but can you tell us when exactly the rollover to the VAB building is going to be occurred? You said a couple days after the launch of 134 means about May 18th or 19th. Then when it is going to be rolled out to launch pad. I heard that it's going to take about 2 weeks to repair the pad after the launch. If that's correct, I would like to know, is it going to be around May 30th that 135 Atlantis is going to be to the pad? Could you tell us about those dates, if it's possible?
You want me to take that one?
I'll go. We'll see a couple ways to answer that. First of all, we don't want to bring Atlantis over from the orbiter processing facility to the vehicle assembly building until we launch. We just don't want to get that vehicle in front of the launch vehicle, and so it's going to follow the launch. Right now on paper, it's a day or 2 later. We're going to need to study that to make sure from a workforce perspective it makes sense. And then what you mentioned about the launch pad turnaround is exactly right. We normally bookkeep 14 days to turn the launch pad around to get it ready for the next vehicle. If we don't have as much damage as we typically do, we could shorten that. If we have more, then it's going to take longer. And so, a couple of days after launch, we'll know the condition of the launch pad, and then we'll be able to set those dates very, very firmly. So until then, it's kind of speculation, but that's the sequence of events anyway leading up to taking Atlantis out to the pad for the final mission.
And one thing, just because there's a lot of folks trying to do the math at home, the VAB flow, when we normally go in the VAB, that's typically a week by the time we get in the VAB till we roll out to the pad. We know we're going to be in there longer this time than a week because the pad turnaround itself is what's holding us up. So we'll get Atlantis over. We want a couple extra contingency days in case something goes wrong while we're doing the mate. But so that the time that we normally would have between OPF rollout and VAB rollout is going to be a little longer than normal. And then our pad flow is going to be a whole lot longer than normal because we're going to have to do a tanking test on our external tank. ET-138 has the cracked stringer condition that we were worried about, and we added reinforcing on the flanges of the inner tank. And so we want to go load that up with cryogenic propellants and then drain it and then go in and X-ray the whole flange. And that's about a 5 to 6 day process to do those X-rays. So the act of doing that tanking test, configuring for it, deconfiguring for it, taking all the pictures, makes this pad flow a very non-standard pad flow. So if you're trying to do the math at home of what, if we say that we're going to roll on the 18th or we're going to do 2 days after launch and then you need a week and then you need 36 days, you're going to come up with the wrong answer because it's not that typical pad flow. And that's one of the reasons why this one's so challenging. There are a lot of extra constraints on the STS-135 mission.
One additional question. I heard a little rumors that you are considering about the July 4th launch for the last space shuttle. Is that right? Is that possible?
Yeah, so that was never a target from a standpoint of a fly on July 4th. We knew we were on June 28th, and we knew fairly early on, within about a month or two ago, that we were going to need a little extra time. That had the potential then to move us to July 4th. A lot of folks locked in on that. I think the delays we're looking at here are going to push us past that, and so we'll be looking past July 4th before we're ready to launch. But no, it was never a specific target for us.
So much for my PAO plans. Okay. We'll go to the phone bridge now and take a call.
Yeah, Mark Kirkman with Interspace News. Can you hear me?
We can.
It was definitely a good briefing by Mr. Moses and thorough, but I do have just a couple clarifications I'd like. The first is regarding the test you did in the OPF. It's my understanding that the only time those heaters usually get tested is through the on-orbit mid-flight cycling of the strings. So I was just wondering whether this particular OPF test is considered an abnormal test for a flow. And then the next question is, I just want to make sure that I think I already know the answer, but I just want to make sure I hear it from you. If the heaters do not come on during the launch count, that effectively kills your current flight rationale and is an LCC violation. Is that correct?
Let's see, Mark, on your first question, a full functional heater check does not occur normally as part of the flow, but they do check functionality of the over-temp thermostats, and so that is checked every OPF. We added a mod to this system a couple flights ago to put an extra heater leg down in the GN2 quick disconnect area to keep that line from getting cold. And about the same time in reviewing all the procedures, we decided that it would be prudent to check out the over-temp thermostat functionality to prevent a hazard. And so that was what was going on. It was the over-temp thermostat checkout that was occurring in the OPF, and that is a standard test. As far as the LCC violation, we're going to be in a much different posture on launch day than we were the last time if this failure reoccurs. I'm not committing to say that means we can launch without one of these heaters. We'd have to go assess that, and that's exactly what the teams are doing. But a lot of the unknowns would be taken off the plate. On launch day, we didn't know if this was a failure in a heater, in a wiring bundle, in an LCA box that has hundreds of functions in it. You didn't know if it was going to get worse as you started vibrating the system on launch. And we've basically gone away and were able to remove a whole lot of root cause from that problem, such that you could postulate that you could get yourself comfortable, potentially, that you could isolate if this heater failed again, that you knew it was in the heater element itself and only that, since that's the only component we did not change out. And therefore, it's an isolated failure. You don't worry about it propagating, and you might be ready to go. Now, I'm postulating we have not had those discussions, but that's what's going to be occurring between now and launch day.
All right, thank you very much.
Any other questions in here? Team? Marcia? Front row, sorry.
You mentioned that you have to stop the window before the next Soyuz arrival. Is that in a problem port, or why couldn't you bring in a Soyuz while the shuttle is there in this circumstance?
It kind of follows to our generic constraints. On an undocking, you're basically leaving and departing the area. That's a fairly easy trajectory to do an analysis on. When you're coming back in and redocking, that's when things get a little tricky. I can't tell you that I looked at the specifics of why this one is not a dual docked ops candidate, although I know it's on the list of one that isn't, probably because it's going to a different port. But again, Marcia, I haven't looked at the specifics for that one.
And Mike, you talked to law authorities. Did they give you any kind of crowd estimate that they're expecting Monday?
No, we haven't gotten an update from them. We've asked that for that data. We'll get that later this week. I don't have it for you today.
James?
James Dean with Florida Today again. Sleep shifting, sorry. Mike Leinbach, wonder if you could just speak a little bit to how the launch teams handle that. When will they start? And I know you've done it many times before, but how much of a strain is that on the folks on the ground? Obviously, they have to be around families living their lives on normal time. How do you deal with that?
Well, it varies by system. Some systems power up at the beginning of launch countdown and remain powered up through the whole launch countdown. Some don't come up until the final day. So it really kind of depends on the system we're talking about. But going into a countdown, every individual that works the count or works the pad closeout operations or on an analysis team, they understand the time of day and when their expertise is required. And typically, I'd say about 2 or 3 days before your key time on console, you're going to start thinking about sleep shifting a little bit. I do about 2 days out myself. And, you want to start getting ready for it. It varies a lot by system. You kind of get used to it. That's one of the reasons we don't like doing 3 in a row at an odd time of day because that does throw off your circadian rhythms to an extent. But people are used to it. People get they're in it to launch the shuttle, and we're going to do that, and we're going to feel good about it.
Okay. Bill, you want to go to Harry?
Just one quick one for me, for Mike Moses, just to follow Mark Kirkman's question, make sure I understand that. If you get down to launch day and you fuel it up and for whatever reason, one of those heater strings isn't working, you're saying there's some chance you could launch anyway, even though you wouldn't have any redundancy in that system?
Yeah, we're going to go talk about that and see if that's the right answer. I could give you my personal opinion now, but it's not based on all the details, so I'm not ready to make my personal opinion or make my decision yet. So we're going to ask all those questions and see how people think. There's a reason why we need 2 of them in the first place, and some of that is for the functionality of the system, but some of that is also for that you don't know why the failure happened. If we can take the why the failure happened off the plate, this could become a different risk discussion with respect to the go, no-go for launch. So we'll go have those discussions, and we'll see where we end up.
And I just might add, Bill, that our launch commit criteria have not changed and are not planning to change before next Monday. So we would have, if one of them failed, we would have a launch commit criteria violation. But per our standard processes, we're able to get together as a team and talk through the rationale for why it would be safe to fly anyway. You don't like doing that on launch day, but we certainly have that capability. That's why the launch commit criteria are written the way they are, and it gives the mission management team and the launch team and the flight control team some latitude to talk about a particular failure and come to a good engineering judgment if it's still safe to go that day or not. And so that would kick in next Monday if we had another failure. I'm not saying how it's going to turn out, but we would go through our standard process of talking about that failure and see if it's good to go that day or not.
Okay, Irene.
Irene Klotz with Reuters. On the scheduling, is there anything after the blackout period for the Soyuz arrival that would impede a launch, or what do the windows look like kind of beyond the May 26th?
So we'd push out into June. It's effectively the same window that we were looking at for the 135 mission. That would be the next window that we could launch. I don't think it was the 28th. I think it was the 22nd or so. Again, those dates have moved a little bit since I last looked at that, but there's basically a beta cutout that comes right after that, and so I think we'd be, if we didn't make it in the end of May, we'd be moving into the middle to end of June.
Thanks.
Okay, any other questions? One more for James in the middle, in the front.
Thanks again, James in Florida Today. Can you give us an idea of what your windows look like for the 135 timeframe that you're looking at now, mid-July or later?
You mean in
whether
terms of available launch windows?
available launch windows, whether it's for beta cutouts or visiting vehicles, et cetera. Are there any? Is it tricky or wide open, or what are your?
For the first bit, most of the beginning and I think actually most of July is wide open, and so I haven't looked at the range schedule. I think there's a Delta 4 in there somewhere that we'd work around, but other than that, I think we're pretty wide open in July. Beyond that, I haven't looked.
Okay, not seeing any other questions. The video that we showed during Mr. Moses' opening comments, we'll play it again at the very end of this briefing, just so we can have it out there. And also the graphic we'll be posting on our website, the main shuttle website. Our next STS-134 related event will be crew arrival on Thursday, May 12th. That's when Endeavour's 6 astronauts arrive at about 11 a.m. Eastern time, and we'll have live NASA TV coverage of that arrival for the STS-134 mission at any time. Any updates will be online at www.nasa.gov/shuttle. Thanks for joining us, and we'll see you Thursday.
I see where it goes in.